Welcome back to another hot and sunny day in Thailand. And by hot, I mean hot. We are almost in April, which is the hottest month for my town here in Hua Hin. And it gets so hot, even the Thai people complain. So we all just try to survive and get through till the middle of the year when it starts cooling down again. What I'm going to do is take a little bit of an accelerated part of something I wanted to do later and move it up. I've been spending a lot of time working on the wiring of my simulator, working on the firmware that goes into the JevQ. I've got a handle on that, and I've started writing the code to support my controller, which I'll pull the data from over CAN bus. And I've also spent a lot of time working on the battery pack. I ordered the batteries from China 2 months ago, and I finally had to cancel the order because the vendor was just stalling and stalling and stalling and lying and lying and lying about sending me my batteries. Their website says they can do 10 million battery cells a month. I have zero. So I have to start all over again and find a new supplier. So I've been spending a lot of time on that, and I have been riding the bike. And here it is in the lab, also known as my condo, and you can see how much space it's taking. I can't even sit down in my chair because that's where the bike is now. And the projects that I'm accelerating have to do with actually riding the bike in a useful way. Right now, I use this GoPro camera, which is a knockoff piece of crap with a terrible battery, and I always have to make sure it's charged before I go for a ride. And I pop it into the front of the bike here, and I always have to power it on and push the record button, and then whenever I park, I have to take it off so it doesn't get stolen. So I'm tired of doing that. So I'm accelerating the project to add the new dual camera battery system. This is the base unit and the wires that go to the forward and rear cameras and the power supply for that. So that'll be part of the project. The other part of the project is providing power to the tablet, which fits nicely into the 3D printed tablet holder, which I'll show you in a moment. So the tablet slides in here. It actually goes in and out quite nicely. I think either the nature of the 3D material is loosening up a little bit, or I've just slid it in and out so many times that it's found a happy state. Now, as you can see, the bike's pretty dirty. I haven't washed it in a while, and it looks like some kind of mutant eagle took a giant crap all over it. So I'm going to clean that up. And the second part of the project is to provide power in the form of a USB cable that comes out and into the power hole right here in the side. So the bike is constantly making sure that the tablet has enough charge. I've actually run out of charge on the tablet because I let it go for a couple of days. So that's what I'm shooting for. In order to make all the power up here happen, to supply the tablet and the camera system, I've got to take the front DC to DC 12 volt power supply. I'm going to take it off the simulator and put it into the front of the bike under here, run some heavy cable back to the battery pack power points under the seat, and that will basically give me clean power to the front of the bike. I'm also considering moving the power supply for the headlights, the LED headlights, to that power supply because the little DC to DC converter that's under there right now is so underpowered that when the lights are on and when I turn the blinker on, the lights dim. I can probably show you that right now. So the lights are on, and I put the blinker on. And I'll cover that up. I don't know if you can see it, but the LED headlights definitely flicker as the blinker light's going on and off. You can see it a little better in the reflection off the chair and the wall. So that's a minor problem that I need to solve also. So it's going to involve tearing all of the bodywork, basically take the bike down to a shell, run some tubing, and then run the wire in it, hook everything up, mount the power distribution point, mount the new DC to DC, mount the cameras, attach the power supply cables, and go from there. Let's get started on the teardown. Okay, I've unscrewed the front fairing, and my past horrific actions have come back to haunt me. This is the headlight connector. In my wildest dreams, I hate this thing with a passion, so that will be replaced. And this is the blinker connector. And under that massive electrical tape is the headlight connector. Both of these will be fixed. Okay, things are reasonably torn down. I've got the whole front fairing apart and a protector on the front fender. I've got the seat out, which exposes the motor controller and all the battery connections. What I'm going to do is run this plastic conduit, which is about an inch, maybe a little bit less than an inch in diameter. And I had to buy 30 meters of it. It's 20 millimeters in diameter. I'm going to run that up into here and down along the hydraulic brake cable. I'll zip tie it to there, bring it around and up into the back, and that'll let me run all the wire that I need to. It'll be protected from the elements, and everybody's happy. Okay, here's all the stuff I need to get inside the front fairing. This is the main 12-volt front power distribution bus. This is coming from the back, so this will be replaced, and it'll go through the conduit. Then we split out two ways. This little DC converter gives me two USB jacks. One will be used for the tablet. The other one is unused at this time. Then we also tap off for power for the camera system. And this is the camera that is in the front fairing, and this is the camera that is in the rear. There's a long extension cable that will go there. And this actually mounts outside. I thought about making a 3D printed bracket for this, but the more I look at it, the more I feel that this will be sufficient for what I need, because it has an angle, an adjustable angle and a sticker on it. So the main thing I need to do is mount that and mount that, and then run the conduit and wire everything up. Okay, after a lot of fiddling, the charger system is in place. This is the mini USB connector that will come up here and plug into the tablet. I've run that down through the bottom of the top fairing, comes down here, and it connects into, there's a USB junction right here, and that comes back around and comes out of the USB power supply, which is routed to the bus bars. So this is all zip tied and double shrink wrapped, and more zip ties and more zip ties to hold everything in place, because even the bloody 3M automotive tape wouldn't hold this in place, so I had to zip tie it in. Okay, next step is over on this side somewhere is where the camera system guts are going to go. All right, let's test it out. I've got the voltmeter across the 12 volts, and I've got 12 volts coming in from my 12 volt power supply. So if I turn that power supply on, we've got 12 volts. The cable, USB cable, is plugged into the tablet, and if you just heard the beep beep, we are now charging. Okay, well, I forgot the cardinal rule from back when I was designing circuit boards. Cardinal rule, I wonder where that comes from. Probably the Catholic Church. Cardinal says, do whatever you want, just don't get caught. Maybe. I'll have to look that up. Anyway, the problem is, or the cardinal rule of circuit board layout is place the big things first where they need to go. And this is the DC to DC converter that needs to go somewhere in here. But of course I placed the bus bar first, which I think will be okay in the end. I think I'll be able to tuck in the DC to DC somewhere around here. This is the metal front fork pivot right here, and there's actually a little metal angle plate right here that the bottom of the DC could fit against. Then it's just a matter of mounting it like this, mounting it like this, mounting it like this, and being able to securely attach it. Zip ties have worked for me well so far. I may have to make a 3D bracket that goes around this curve and it's flat on the sides that gives me something to bolt against here that will then allow me to attach that. So let me get to work on that. Okay, here we have the version 1 prototype of the DC to DC bracket. It's printed in super fast mode because I just need to get an idea of how things fit. And as you can see, they fit comically unwell. But just take a look. So this is designed to go like this. The tab at the bottom is too long. It doesn't fit above that metal bar right there, so I've got to work on that. The DC to DC converter actually fits into the space for it quite nicely, but at the top I need to make a recess for that plastic, the black rubber, I don't even know what that is, a kind of a gasket. It's preventing it from seating correctly, so I need to allocate space for that. And it's just far too big. Look at the size of that. Is like this, and this is like this. So this was the cardboard template that I made, and I just completely botched the measurement in CAD, so I'll redo the Bezier splines for that and re-extrude it. I need to make the holes bigger for the zip ties in the corner. There's going to be a zip tie that goes all the way around the bar and comes back the other side through these holes. I think I'm going to put another zip tie to hold the top of the DC to DC in. I'll run a zip tie through this strip and it'll go in here through the shell, come out this side and back up around here. The bottom one, the zip tie will go in this little opening here and go all the way around. Because of the depth of this bar, I can actually get one around here, but here, you can't see because it's really dark. This is a piece of welded steel all the way back to the tube that holds the front fork in place. But I can get something around the top here, and I can get something around the bottom here. So, let's work on version 2. Okay, here we have version 2 of the CAD design. We've added the slot for the rubber gasket. I've increased the size of the holes for the top zip tie. I punched a hole for the side zip tie. I shortened and strengthened this little tab at the bottom, and I redid the tube section so it should fit tighter here. Hopefully what I'll do is maybe put a very thin piece of rubber in here to absorb some of the shock. But I think this is pretty good for prototype number 2. So let's print this out. And here we have version 2 of the bracket holder in place. The DC to DC fits in quite nicely. Fits around the rubber gasket at the top. And it's quite snug in place. Everything looks good. It's perhaps a little bit thicker than it needs to be. Maybe I can slice out a little bit of material, maybe, I don't know, 1/4 of an inch. But it fits nicely at the bottom. The only thing I see is this actually moves with the handlebar to hit this metal plate, which is the turning stop as you go from right to left. So you can see that. I don't know if I can get an angle underneath, but that bracket, that bracket is just barely touching the bottom. The bottom of the bracket's barely touching this stop part. If I pull it out, you can see the rubbing. So what I'll do is I'll shave that off in CAD. Otherwise, it looks really good. I'm pretty happy with the way version 2 turned out. And what I'll do is I'll glue some rubber in and then zip tie that in place on the final version. And then we can move forward. I'm pretty happy. Version 2 is usually not great. There's still a lot of refinement, but this one worked out pretty well. Okay, after 7 hours of printing, 33 meters of material, and about 1/4 of a pound worth of PLA plastic fiber, I have my DC to DC bracket. And I moved the wires out of the way, so if we pop this in, it goes in with a very reassuring compression fit between the bottom of the bus bar and that metal bracket. And I can move the forks from one side to the other. There was no interference. That'll be fine once I get the zip tie on. And then we put the DC to DC in place, and that fits in perfectly. So next step is to zip tie the DC to DC to the bracket and zip tie the bracket into place and hook up some wires. Alright, I hooked up my 60 volt power supply. 60 volts coming in, 12 volts reading on the out onto the bus bar. The USB power is on, and we are charging the tablet. So that's all good. But before I do that, I figured I would wire in the camera power supply, which is this little module right here. It's lying gently in place approximately where it's going to go. It's got this crazy power supply lead that was about 8 feet long, so I preserved the connector, but I shortened it up, wired it into the bus bar, 60 volts into DC to DC, 12 volts out, and boop. We have power and 2 cameras. This camera and this camera. I'm waving my hand in front of that camera, and I'm waving my hand in front of that camera. So I can be riding like this, or if I'm just going, this tilts away and I can shut off the LCD somehow. I don't know how to do that yet, but it will still record. If I ever want to see what's going on or work with the menu, I tilt it up, do my thing, and then push it back down. Hopefully it won't be too obvious to people walking past. It'll just look like a little dark box with some wires. I don't know. We'll see if it gets stolen, but that's life. Okay, as they say in the space industry, the vehicle is under its own power. DC to DC, terminal block, and we've run the conduit from here all the way to the back. We've got 60 volts DC coming through, which is joined into the 60 to 12 volt DC to DC. And I've left what we call a pull wire in the industry. One thing I learned from my solar buddies, when you're running conduit, there's always another thing you need to pull through that wire. So I've left this as a pull. I will, if I need to bring something else through, I tie it to the other side, then I pull this wire through, and then you go back and forth a couple of times to make sure you have the pull wire ready for your next wire. Anyway, so this is buttoned up. I have mounted the front camera here and aligned it, because you can turn it in a circle and align it. Everything is buttoned up nicely. Point of information: people debate about the mankind's greatest discovery / invention. Some say wheel, some say fire. I say zip ties. Civilization would fall apart without zip ties. Anyway, I'm leaving the connector for the blinkers and the headlights for now. We come around here. We can see where the other side of the conduit comes through with the pull wire, 60 volts, and the camera. Camera comes up here. It's zip tied, but there's a couple of places where I'm going to use just some silicone sealer to hold it, because I don't really want to drill through the bodywork. And there's the rear camera, all ready to go. And let's turn on the power and see what happens. So the tablet is now charging. The camera system has woken up, and we have a live picture. Focus. So here's the rear camera. Hello. And there's the front camera. Hello. So I'm pretty happy. I actually tapped into the 60 volts. I brought the wire all the way around to have plenty of space for when I put the permanent controller in place. Wired up, tapped into the 60 volts coming from the battery, and everything's good. So the last step is going to be doing those connectors on the front for the blinkers and the headlight. Then I can button it up and get back on the road. Okay, let's kick off the last electrical part of this mini project, and that is wiring up the front fender electrics to the bike with a proper connector system. So I've got two things that I need to get. One is the headlights, and one is the blinkers. The headlights are high beam, low beam, and ground, so that needs 3 wires. The blinkers, there's 2 for the left and 2 for the right. I initially thought I could get away with kind of a left, right, and ground, but because there's a blinker in the front and a blinker in the rear, I think it might be a circuit. So basically the bulb needs an in and an out, and it's in series in the circuit rather than just lighting up on the application of plus 12 volts. So here's the thing. So I need 3 wires for headlights and 4 wires for blinkers. Now let's take a look at the connectors that I've got. When I was back in America last fall, I went crazy looking for and buying connectors because it's so hard to pick something over the internet from China. I wanted to see them and touch them and feel them and see how they worked. So I came away with 2 major types. The first one is this kind of commodity plasticky thing. It feels awful. It's wiggly, and it has almost no holding power. There's no positive clip. There's a tiny little bump right here molded into the plastic shell. I don't know if my focus is going to get that. A tiny little bump right there that goes into the tiny little slot, and it takes almost nothing to pull these apart. But it uses this pin system, and here's a female pin and a male pin, and they go together like this, and the force is pretty strong with this. That's a significant amount of force to pull apart. It's probably twice the force to actually pull the connector apart. And if I've got 6 of these in a connector, that's pretty strong. And I can even, wrap a zip tie around it or something ridiculous, because I'm not going to be taking the front fender off much anymore. But the problem is, the pins I have, or the connectors I have, there's a 12, which is overkill, because I need a total of 7. Then I've got these 6s. Then I've got a couple of 4s, and I've got a couple of 2s, a few 2s. So there's no such thing as an 8, or I didn't buy the 8. There's certainly no 7. So I'm going to have to go with a 4 for the headlights and a 4 for the blinker, and use these the pins and hope for the best. It would have been nice to have it all in one connector, but if they're placed in different places with different lengths of wires, that would prevent me from plugging the wrong connector into the wrong place. As a side note, I also bought a bunch of these gland nuts, which I will be using when I put the JevQ and all of this stuff, the contactors and the pre-charge relay, all goes in a sealed box under the seat. I'll be using these to run the wires in and out. I used these extensively in the Porsche project, so I needed those. Now let's take a look at the other connector technology that I found, and that is these guys. These are amazing. Short. Nothing short of amazing. Let me get 2 that I can actually take out. Okay, so here's a 2. This is a 2 connector. You can already see the waterproofing or water resisting little rubber thing. This is very flexible rubber or silicone or something, and they snap together like heaven. This is amazing. They don't pull apart unless you give it a gentle pull on the catch release, and they come apart. They are incredibly solidly made, and both of them, each side, has this kind of a shroud and a lock that's difficult to take off. Let's see if I can get it. Let's see. All right, let's look at one that's apart. Here's one. You crimp your connector on, you stick it in here, and then you snap this over like that. And this acts as a mechanical assist. So when you pull wires, they are being mechanically held from being pulled out of the shell. These are genius. These are just simply amazing connectors. And I've got them in several sizes. I got a 2, I got a couple of 4s, and I've got a 6. So again, no 7s, no 8s. I could do 2 of the 4s, but frankly, that leaves me with nothing. It leaves me without a 4. And I was thinking about saving these more for use down wiring up the controller, because it's got a lot more responsibility for making the bike work properly, and I want to have ultra good connectors for there. Another crazy thing is the pins for these connectors. A bag of 100 was over $50 for 100 pins. That's 50 cents a pin. Now, where I bought these connectors in Santa Maria, California, at a really great electronic shop, the guy did give me a discount, because this is about $250 worth of connectors and pins that I bought from him. So he was a nice guy and gave me a discount. But I think what I'm going to do is save these for working down in the controller area, and I'm going to use the cheap ones up front. I did also buy this one. It's an Amphenol. It also looks quite amazing. It's got a rubber gasketed on both sides. Very, very, I mean, it feels so good in the hand, the way it matches and latches. But again, I think I'm going to save that guy for a 6, because I need a 7. So let's get started. All right, the lights and blinker connectors are in place. Let's try the lights. Low beam, high beam, low beam, high beam, excellent. Left blinker, Right blinker. Excellent. Let's go to the back. Left blinker still works. Right blinker still works. Okay, let's button this thing up. I want to do a brake adjustment, put it all back together. Okay, I'm out in the parking lot, and it's been raining all day, so I'm trying to get this in between thunderstorms. But here is the camera system. Rear camera, front camera. It's recording right now. So I'm going to take a little spin around the parking lot, and the screensaver just kicked in. So let me do that, and then I'll capture the captured footage and put it in the video.
As you stare out on my beach, I would ask you to subscribe to my channel and click like on this video so YouTube thinks I'm worthy again, and I have so many people on my channel that they'll give me 10 cents a day in ad revenue. So I thank you for that.